Look at page 406 in the text, there's one more inverse function that they give us, and it's probably the reason they use this one also is because it corresponds to your calculator. What's the one inverse function on your calculator we haven't discussed? Tangent inverse. Okay, so we're going to do the same procedure again. If you don't mind, I'll erase cosine, or cosine inverse here. This one's kind of fun. So, a little bit of review. What's the period of cosine?
2 pi.
2 pi. What's the period of sine?
2 pi.
2 pi. What's the period of tangent?
Pi.
Pi. And it's really important to remember that. So, one of the things I like to remember, just because it helps me when I'm graphing, I like to remember, I have burned into my memory that tangent of 0 equals 0. Tangent of 0 degrees or tangent of 0 radians is 0 because it helps me remember when I have to graph tangent. So tangent actually goes through the origin. Cotangent does not, and that's one of the ways I keep them separated. And the reason tangent goes through the origin is tangent is sine over cosine. Well, this is what gives us our asymptotes, when the denominator goes to 0. When does cosine of x become 0?
At 90 degrees and 270.
At 90 degrees and 270, or if we talked about that in radians, we would talk about pi over 2. We would have another asymptote over here at 3 pi over 2. Good. We also have an asymptote back here at negative pi over 2. Excellent. And so there's one just period of tangent, but I get an infinite number of them, right? I get another one over here and another one over here, and if I go out another pi, I get one here and one here. Now I'm not going to draw all of those. Obviously, how many of these do we need?
1.
1. We just need 1. So, same procedure again. Wow, look at that. There we go, went through the origin. So here's our line y equals x again, so we can figure out the inverse. So when we rotate it, what is this going to look like? Well, if we're not sure, again, we can take the distance here and put it over here. There's a dot. Take perpendicular distance to the rotation line. There's a dot. Take. There we go. So instead of curving up this way, it's going to curve this way. And then down here, it's going to do the same thing. It's going to have a little dot there and a little dot there, so it's going to go like this. So it's going to look, it's not a great diagram, it's going to curve and look like that.
Doesn't that still go through the origin?
It does still go through the origin. That's why there's a really big dot there.
Yeah, what's the one that doesn't go through the origin?
They both do.
No, that you had to remember 10 of 0 equals 0.
Oh, cotangent. Cotangent doesn't go through 0. It's offset by 90 degrees. So for tangent inverse, it comes up like this. Now, we had vertical asymptotes this way, and I'm going to get rid of a little bit of the clutter if you'll allow me. Let me just redraw this. Now that we have an idea of what it looks like. So we saw that it comes up like this and goes like this. So this is tangent inverse. Tangent inverse of x. So if that's tangent inverse, we had vertical asymptotes where?
Pi over 2 and negative pi.
Yeah, when we were here, we had them at pi over 2. We had another asymptote at negative pi over 2 here. So those are also going to get rotated, and they're going to become horizontal asymptotes this way. So do you remember how we said that sine and cosine waves, they're always bounded between 1 and minus 1? You know, but tangent wasn't, because tangent went to positive and negative infinity. Well, a funny thing happens. When you take the inverse function, it gets bounded. Because what were those vertical asymptotes are now horizontal asymptotes. So your values of tangent inverse will always be between pi over 2 and negative pi over 2. Or if you had your calculator in degree modes, what degrees are those?
90 and 270.
Yeah, excellent. 90 degrees and 270. Now look at the unit circle. What quadrants does that correspond with? Positive 90 to,
So 1 and 4.
yeah. And what function also corresponded to these two quadrants?
That'd be inverse of cosine.
Sine, with sine inverse. Sine inverse took all of our values from it. Cosine took from these two. The reason is we could have taken our values from quadrant 1 and quadrant 2, but then we're going to have an asymptote. We're going to have two branches of the graph. If we had, here's tangent. Now here's my next, I have another branch of tangent over here, like this. I could have said, well, sure, I'll just take this part of this branch here, and I'll just take this piece of this branch here, and that gives me all the values of tangent, but then I have a big discontinuity in the center, which doesn't seem like a very smart way to do it. So if I'm going to grab the whole branch, it's got to be between positive 90 and negative 90. Make sense? So on your calculator, if you put in tangent inverse because you need to find out how big an angle is, you're always going to get answers from first quadrant and fourth quadrant. Now that's great if your proper answer is actually first and fourth quadrant. What happens if your answer is a second or third quadrant?
Adjust.
You're going to have to adjust. Now I can give you a quick example of this. And this is why we talked about reference angles so much last chapter and why they're important. You really have to understand reference angles. So if I ask you over here, let's just make a quick diagram. We'll do a 3, 4, 5 triangle. 3, 4, and 5 triangle. And I ask you, what's the value or what's the coordinate of that point right there? Well, there are a couple of ways you could figure it out. If I say, I want to know what that is. Well, actually, you know what that is. It's minus 3, 4. Let's say we know the point is minus 3, 4. We want to know what this angle is. How would you find that on your calculator?
Take sine inverse.
Okay.
4 over 3.
Okay, let's use sine inverse 4 over 3 and see what happens. Now, we're going to remember that the direction in this case doesn't matter, so that's going to be negative. Even though we know it's distance, that's 3 positive units. For our sine and cosine functions to work properly, we have to include the minus signs, yes? So go ahead and take out your calculators right now, and we're going to say, what is sine inverse? Sine inverse, well, and in this case, here's sine, it's going to be 4/5. Mind your way, Emerson?
Okay.
You see all right? Yeah. And then I want you to take a look at what is cosine inverse of 3/5, because for this triangle that would be the inverse, right? And then let's do the same thing for tangent. Tangent's opposite over adjacent, so let's do tangent inverse of 4 over minus 3.
Do you want, for cosine, do you want, okay.
Yeah. Thank you for catching that. So tell me what value you get for sine inverse.
0.927.
And let's go ahead, just for the time being, let's go ahead and make sure that our calculators are in degree mode rather than radians mode. Let's get degree value for this because it'll be easier to look at. And I'll trust you to do this because I don't have my handy dandy calculator in front of me.
53.13.
Okay, so when you put sine inverse in, this says 53.1.
3, yeah.
What does cosine inverse say?
126.87.
126.8. Okay? What does tan inverse say? Negative 53.1. Gee, your calculator must be messed up. It can't decide how big the angle is. You do tangent inverse, it says it's negative 53 degrees. You do sine, it says it's positive 53 degrees. You do cosine, it's 126. Which is it? clearly, if you look at the diagram, it's 126 degrees. Now you know it's 126 degrees because you know it's a second quadrant angle. Here's your first 90 degrees. So, and here's your next 90. So you know that the proper answer here has to be somewhere between 90 and 180 degrees. The only value the calculator gives you that's between that is here. Well, what's going on with these two?
They have to be from the first and fourth quadrant.
See, that's the problem. The problem is that for both sine and tangent, the only answers your calculator can give you are from first and fourth quadrant. Is this a first or a fourth quadrant angle? No, it's a second quadrant angle. So, you know, I've done this long enough that I can usually say, oh, I'll just choose cosine inverse for this problem because I don't feel like having to, you know, use the reference angle and change it. And if you think that way, you can save yourself some time and effort. But the point is, when you're using these inverse functions, you have to be extremely cautious. You always have to say to yourself, okay, what quadrant should my answer come from? So that if I do something like a tangent inverse, which gives me negative 53 degrees, I know, wait a minute, that's fourth quadrant. So that means this is 53 degrees here, and so what do? I take that reference angle of 53 degrees and I add it to 90, and I'll get what I need. Let's give that 126.
Yeah.
Because this is my 53 degree angle over here. There's my reference angles. We always do reference angles from the x-axis. So we'd subtract it from 180, don't add it. You follow? Excellent.